Torsional frequency of one disk shaft. That means one end of shaft is fixed and another end having one disk attached to it. Of one disk shaft frequency using a standard formula. A standard formula to be used for calculating the torsion natural frequency of the shaft having one end fixed. Using this formula, only one, that is first torsion frequency, is calculated. For higher modes of frequency, Holger methods to be used. The two important parameters required for formulas are mass moment of inertia of disk and torsion stiffness of the shafts. So we need to calculate the mass moment of inertia of disk and stiffness of the shaft. Mass of the shaft is neglected for calculating torsion frequency. Mass moment of inertia of disk about axis of symmetry I is equal to m into bracket start do square plus di square bracket closed upon 8, where do di are in outer inner diameter meter, m is a mass in kg. Polar moment of inertia of shaft J is equal to pi into do to the power 4 minus di to the power 4 bracket close upon 32, where do di outer inner shaft diameter in meter. Using a standard formula of torsion, T by J is equal to G theta by L. So T by theta is equal to Gj by L. So torsional stiffness K is equal to T by theta is equal to Gj by L, where L is the length of the shaft and G is the shear modulus of rigidity. G is equal to E upon bracket start 2 into bracket start 1 plus Y bracket close, where E is a Young modulus of elasticity in Pascal, Y is a Poisson ratio in constant, and G is also in Pascal. Shaft length of same diameter. This is one end fixed, another is having one disc attached, and diameter of shaft is uniform, is same. In that case, torsional natural frequency omega is equal to a square root of complete square root of K upon I, where K is the torsional stiffness of the shaft, I is the mass moment of inertia of the disk. It will give radian per second. So in case of Hertz, F is equal to omega upon 2 pi. So using this formula, torsional frequency is calculated. When the shaft length of having different diameter, in that case, you need to find out torsion stiffness at each section of the shaft using the same formula with the varying length and diameter, and then effective torsion stiffness is calculated, which is 1 by k is equal to 1 by k1 plus 1 by k2 plus 1 by k3. अगर इससे ज़्यादा है तो भी ऐड करना है. Then effective torsion stiffness k is equal to 1 upon bracket start 1 upon k1 plus 1 upon k2 plus 1 upon k3 bracket close. In that case, torsion natural frequency omega is equal to square root of ke upon I. In case of Hertz, F is equal to omega upon 2 pi. So we understood now how a standard formula is used for calculating, one disk system where another end of shaft is fixed. Even also we know if diameter of the shaft are different between, disk and the fixed end, then you have to calculate effective torsion stiffness and use this formula. So hope you like this. Thank you for